All right, welcome to page 3. Again, I'm sorry this is the way that this is having to be represented, but just working with what I have today. Example 3, suppose that a large mixing tank initially holds 300 gallons of water in which 50 pounds of salt have been dissolved. Another brown solution is pumped into the tank at a rate of 3 gallons per minute when the solution is well stirred. It is then pumped out. If the concentration of the solution entering is 2 pounds per gallon, determine a differential equation for the amount of salt A of t in the tank at time t is greater than 0. So we're going to assume that the output rate is going to be 3 gallons per minute. So since A of t denotes the amount of salt in the tank at time t, then the rate at which A of t changes is just going to be a net rate change. How much is inputted minus how much is outputted. So then our differential equation for total amount of salt is just going to be Rn minus R out. So Rn, so what we have is 2 pounds per gallon. So 2 pounds of salt in our concentration is the inflow. So we have 2 pounds per gallon we have 3 gallons per minute. So this is how much brine is coming in. So then this gives us 6 pounds of salt per minute for how much is coming in. For R out, A of t represents the total amount of salt in our mixture, and then we're going to divide that by pounds, divide that by 300, because that's our total gallons of water in the tank. So we have A of t, which represents pounds of salt per gallon, times 3 gallons per minute. Again, this is the output. Again, output, which is stated by here, so 3 gallons per minute. All right, so we have A of t over 100 is going to be our output of pounds per minute, because the 3 and 300 are going to cancel, well, not cancel out totally, but 3 divided by 300 is just 100. So I'm sure you all can see that. So then our rate of change for the total amount of salt with respect to time is just 6 minus A over 100, all right? Or dA over dt plus 1 over 100A equals 6. Again, it doesn't matter which way you write that, all right? But that's the solution for when we have an output of 3 gallons per minute. Now suppose we have an output rate of 2 gallons per minute where everything else is going to be the same. So then that means that our Rn is still 6 pounds per minute. Let me zoom out so that you can see that up here. But now our R out is going to be 2 gallons per minute. All right, so there, it's going to take that place. But then, you know, because more is coming in than is going out, we have 3 gallons per minute coming in as opposed to 2 gallons per minute going out. So we're going to have an extra gallon every time we go through time. All right, so hopefully that makes sense, because after every minute we're getting one more gallon into our tank that is leaving, because the output's a little bit less than the input. And so that means after 5 minutes, I'm going to have 5 more gallons in the tank, because I'm adding a gallon every minute. So that's why when we put, when we have a total concentration, we have our total amount is going to be divided by 300 plus t, where t represents time, and this t is also going to represent how many gallons. So after 5 minutes, we'll have 5 extra gallons. All right, if after 10 minutes, we'll have 10 extra gallons. So that's why it's A over 300 plus t. Say if this was 1 gallon per minute, then we would have, 2 gallons per minute more coming in. So that could be 300 plus 2t. So I just wanted you to see where this 300 plus t is coming from, because we're having more gallons added per minute. So again, after 7 minutes, we're going to have 307 gallons in the tank. So then our R out is just going to be 2A divided by 300 plus t. Just multiply across, pounds per minute. So then our differential equation is equal to 6 minus 2A over 300 plus t.